Hello. In this video, I will do a GED video regarding multiple factors and distributive property. So let's start with the knowledge, uh, pro- yeah, knowledge check, knowledge check tests. So wait, before we move on, we are dealing with multiple factors and distributive property. I want to go over a few rules. So go ahead and take out your notes and write this down. So uh, they might ask for the lowest common multiple. So what is the lowest? So they'll give you numbers and you might have to find the lowest common multiple. So lowest, basically what you want to do is pick the one with the highest base. So once you make your factor tree and you get all your prime numbers, um, once you make your factor tree, circle all your prime numbers, you're going to pick the highest power. I will explain when we do these problems. And then next, then they might ask for the LCD. That's not the same thing as the lowest common. That is not the same lowest common. This is the LCM. That's not the same thing as lowest common multiple or LCM. The LCD is you pick the highest power. You pick the highest power of the repeating base, and then you also pick and anything that isn't repeating. Okay, so you pick the one with the highest power. Uh, so once you make your factory, circle all your prime numbers, you're going to have these prime numbers, and you're going to have some powers. So you're going to pick the one with, if you have a repeating base, you pick the one with the highest power, and then you also include the number that is in a repeating base. So, and then the difference between this and the lowest LCM, the lowest common multiple, you're going to pick the one with the highest power base. So yeah, I'll explain. But right now, I just want you to write it down. Okay, I'm going to clear, and I'm just going to do question one. Question one says three people are jogging around the park and they start from the same point together. The time they take to complete one round of the park is 10, 20, and 30 minutes, respectively. What is the minimum time in minutes in which they can return to the starting point together? Okay, so um, so yes, we're gonna make a factor tree. So what are our times? So we have three people. One is at 10 minutes, the other one is 20, and then the other one is 30 minutes, right? Obviously, this is not prime, so what you want to do is break it down and make a factor tree. By the way, what is a prime number? If you forget what a prime number is, a prime number, write this down, is basically a number that can be times one in itself. What do you mean by one in itself? So for example, 5 is a prime because what two numbers multiply 5? 1 and 5, right? It's obviously one in itself, right? 7 is prime because it can only be times by one of itself. Um, Usually it's odd numbers. 11 is prime, it can only be times by 1 and 11, right? So basically any number that can only be times by 1 in itself. Okay, so here are numbers 10, 20, and 30. Let's make our factor tree. So what two numbers, let's start with 10. What two numbers multiply 10? Any two numbers will do. How about 5 and 2? Then what you want to do is circle the prime numbers. So is 5 prime? Yes, it can only be times by 1 in itself. Is 2 prime? Yes, it can only be times by 1 in itself. Okay, move on. Let's do 20. So 20 can be broken down. What two numbers multiply 20? Maybe 5 and 4. 5 is prime. 4 is not. It can be broken down as 2 and 2. So look at our numbers, our prime numbers, the one I circled, 5, 2, and 2. This now you have the repeat. So you have 5 or 5 to the 1. And then you have this repeat of prime numbers 2 times 2, which is really 2 squared. Okay? Now do the same thing with 30. What two numbers multiply 30? You can do 6 and 5. 5 is prime, 6 is not. It can be broken down as 3 and 2. Okay? None of these prime numbers are repeating, so that's good. Okay, so why did I rewrote 2 on the for the number 20? Why did I write the prime number 2 and 2 as 2 squared? You'll see why. So the question says, what is the minimum time in minutes in which they can return to the starting point together? So yeah, I think they're asking for the lowest LCD. Yes, they're asking for the lowest common denominator for this problem. And to find the lowest common denominator of all your prime numbers, you pick the one with if you have a repeating base, we do have a repeating base. So on 10, we have a base of 2, and then on 20, we have a repeating base of 2, and then on 30, we have a repeating base of 2, well, 2 to the 1. And then yeah, this 2 is the 1. So they said that if you have a repeating base of a prime number, you're going to pick the one with the highest power. So this to the power of 1, right? 2 to the 1. This is 2 squared, and then this is 2 to the 1. So you're going to pick the one with the highest power, so we're going to do 2 squared. Okay. Whoops, I made a mistake. They're not asking for lowest common denominator. They're actually asking for the lowest common multiple, the LCM. I'm so sorry, I made a mistake. So they're really asking for the LCM, lowest common multiple. So this one's a little bit different. With the lowest common multiple, you're going to pick the one with the highest power. No, I'm so sorry. They're not asking for the lowest common. They're asking for the lowest LCD. I was right the first time. Sorry. I was looking at the notes. So they are asking for the LCD. So with the LCD, if you have a repeating base, which we said was a base of 2, we do have a repeating base of 2, pick the one with the highest power. So between the 2 and the 1, the 2 and the square, and the 2 to the 1, you're obviously going to pick the 2 squared because that's the one with the highest power. Then you're going to bring down anything that's non-repeating. So we have a base of 5 here and a 5 there. and so we do actually do have a repeating base of 5, but the thing is they're all to the power of 1. So it's just going to be 5 to the 1. Do you see any other repeating base? No. So then you have to bring down anything that isn't non-repeating. So I have a non-repeating base of 3. So bring that down and put it all together. What's 4 to square is 4 times it by 5 times by 3. That gives you 60. So it would be 60 minutes. So they're asking you what is the minimum time? We're really asking for the LCD. And that is how you find the LCD. Make a factor tree, circle your prime numbers. If you have a repeating base, pick the one with the highest power. Then you bring down anything that isn't non-repeating. So we do have a repeating base of 2. So I'm going to use 2 to the second because that's the highest power. And then I do see a repeat base of 5, but they're both to the power of 1. So that's why I'm going to use 5 to the 1. And then I see a non-repeating prime number of 3. So that's why I brought that down and put it all together. You get 60. There we go. Okay, question 2. Jack is making flowers arrangement for a wedding. He has 16 roses and 24 lilies. All arrangement must be identical. There are no restriction on the number of flowers per arrangement, but no flowers should be left over. What is the greatest number of identical arrangements Jack can make? Mhm. Right, so this is when they say what is the greatest number of identical arrangements Jack can make, I know this is going to be the GC. They're asking for the LCM, lowest common multiple. Right. So what you want to do, sorry, here are numbers. We have 16 rows and 24 loops. So just like the other ones, make a factor tree. 16 can be broken down as 4 and 4. And then 4 can be broken down as 2 and 2. 2 is prime, so 4. And so 4 can be broken down as 2 and 2. And then we only care about our numbers. So we do have a repeating base of 2, but we only care about prime numbers. So we only care about this 2, this 2, this 2, 2. So 2 times 2 times 2 times 2 is really 2 to the 4th. Do the same thing with 24. What two numbers multiply 24? It could be any, so it'd be 6 and 4. Or it could be broken down as 2 and 2. 6 could be broken down as 3 and 2. Okay. Um, I do see repeating base of 2. So we have 2 here, 2 there, 2 there. That's really 2 to the cubed. And then you have a non-repeating prime number of 3. Okay. This is how I like it. I make my factor tree. Simplify it. I see on a 16, I see a repeated base of 2, so they're repeated 4 times. That's why I wrote 2 to the 4th. And then the same thing with 24. My prime numbers are 2, but there's a repeat of 3 of them, so that's 2 cubed. And then my 3. Okay. So what you want to do when you find that LCM, lowest common multiple, LCM, so what you want to do is you're going to pick the lowest repeating prime number. So we're only going to care about the twos because the repeating. I don't care about this three anymore because I don't three is not repeating, right? So I'm only going to use 2 to the 4th or 2 cubed, and I'm basically to pick the lowest. So it's going to be All right, not the lowest, pick the highest. Yeah, pick the highest. So you pick the highest repeating base. So I don't think I'm gonna, so my repeating base are twos, right? Yeah, two to the fourth and two cubed. We're gonna pick two to the fourth because that's the highest power of repeating. So two to the fourth is 16. So it's gonna be C. Okay, next one, the last one. Question three says four friends, Adam, John, Sam, and Kevin express the sum of 48 and 72. So Adam is 48 plus 72 is equal to the same thing as 8 times 6 plus 9. John is 48 plus 72, which is technically the same thing as 12 times 4 plus 6. Sam is 48 plus 72, which is the same thing as 12 times 2 plus 8. And then Kevin is 48 plus 72, just the same thing as 24 times 2 plus 3. Group has correctly expressed the sum of 48 and 72 as a multiple of the sum of two whole numbers with no common factors. I think it would be Kevin. Why Kevin? Because Kevin is here. I'll show you why. 24. So this is Kevin, right? It is 24, and then it's 2 plus 3. 2 plus 3 is the same thing as 5, and then you have this 24. And if you break it down, 5 is the same thing as 1 to 5. 24 is the same thing as 6 and 4. 4 is the same thing as 2 and 2. 6 is the same thing as 2 and 2. Uh, the reason why the others doesn't work because, for example, Adam was 8 times 6 plus 9. It's 15. Um, s- s- 10. John was 12, and then 4 plus 6 is 10, and then Sam was 12, and 2 plus 6 is 10. So as you can see, John and Adam are practically the same. Um, yeah, so that's why we don't use John and Sam because they're practically the same. Why don't I use Adam? Because 1 to 6. Yeah, because 8 and then 15 is the same thing as 5 and 3. 3 is fine, 5 is, yeah, they're, we have a repeating somewhere. See, 3 plus 2, yeah, is 5, so that's why Adam is not the one. There's something that's repeating. Yes, now remember, see this 8, it's the same thing with has an 8 here with Sam, so it can't be nothing repeating. So it's not Sam, it's not John or Adam. This Kevin's the only thing that hasn't a base that's repeating. So it's gonna be Kevin. Okay, this was a very short video, but I'm gonna stop here.